Okay, guys, welcome to ICW for this week. I'm dropping stuff already, no problem. Okay, so remember today what we were working on was similar triangles and rectangles. So big thing is when we're looking at similar triangles and rectangles is the fact that when we are looking at a rectangle, and let's say its dimensions are 1 by 3. For another rectangle to be similar to that one, as it is with all polygons, is that all the angles are the same on each shape. So this one's fairly simple, but if we label this A, B, C, and D, those angles on the second rectangle would be the same. So if this is rectangle 1 and this was rectangle 2, A, B, C, and D are all 90 degrees, as you can see that. So that's the first condition. Second condition is that all sides have the same ratio. That's to the original. So in this one, if I have, well, I do have, this is 1 and this is 3. So when we go over to our second rectangle, if this is, say, 2, this side over here is going to be exactly in ratio. So here we've multiplied it by 2, so 3 times 2 is going to be 6. So if we look at that ratio, the first triangle is 1 to 3, has to be equal to the second one. Over here, now we have 2 and 6. So I get 2 over 6. Another similar ratio or a similar polygon that we could have would be, let's say we multiplied our original, this one here, by 3 on the top and by 3 on the bottom. We would end up with a rectangle that has the dimensions of 3 over 9. In the triangles, for this one, as I mentioned in class, I would like you just to use a regular right triangle. It's going to be a lot easier when you do your project because here, if we have a ratio of 1 to 1, the hypotenuse, we don't really know, but that's okay. Okay, because if we keep this ratio the same, 2 to 2, or if we had another bigger one, even though that's not bigger, this could be 3 to 3, 10 by 10, whatever it is, this ratio from the hypotenuse to the side is still going to be the same. So that's how we know if polygons are similar. In here, because this ratio is the same, these angles are going to be the same as well. Again, so if we have angle A, B, and C, they're going to be the same on this side as well. So your challenge is to use the copy you did in class as kind of a rough draft. For those of you who weren't here, this is what I was talking about. I know it's a mumble jumble, so I will do a good copy over here. I had to reshoot this video, guys, because I lost the other one. So what I want you to use is you are going to use rectangles, or squares, I should say. You are going to use rectangles. You can use different sized and shaped rectangles. And you're also going to be using regular right triangles, like so. And your goal is on graph paper to draw a big rectangle. I'm going to use a square here just because it's easier for the video. And I want you to fill every single square on that page using similar shapes. You must use squares, rectangles, and triangles. So I wonder if I could do grid on here. I think there's a way. Where's my paper type? 1 second here, I'm going to try something. Maybe this isn't the time to do it. I'll figure it out. I think I can actually get graph paper on here. That'd be super cool. No, not there. Let me just try one quick thing. Sidebar, toolbar options, alignment, no. Dual page, no. Okay, let me try one more thing. Page. Set background fill, no. Theme. No, I'll figure that out for another time. So, for example, I'm going to start with the square. Sorry about that random version. So here's a square. So on your graph paper, let's say this is like 4 by 4. Remember, squares have all sides equal, right? So now if I was going to do another similar square, I could do a square over here that's, say, 2 by 2. You're not going to write those numbers on, just make sure that you keep the ratio the same. I can do up to 4 similar for each ratio. So I've got 2 here. I'm going to do a giant one over here. Say this one is like 10 by 10. So that one's done. Now I'm going to move on to some rectangles. So rectangles, let's say I'm going to just take a big rectangle over here. And let's say this one is 4 by, like 20. So an equivalent one of those, if I go smaller, so if I have 4 over 20, if I reduce that, that's also going to equal 2 over 10. So let's say over here I've got a 2 by 10. There it is. Now, in class, we numbered these. So all of the squares would be number 1. All of the rectangles would be number 2. In your homework, though, I want you to color these in. So all of your rectangles of the same ratio will be one color. Remember, they cannot be next to each other for your good copy. And let's do another different kind of rectangle. So I'm going to do a long, skinny one. Over here, this would be number 3. Different color. And I might have a really long and skinny one that's going to be at the same ratio. So you're starting to get the picture, I hope. Now, when it comes to triangles, this is going to be a little interesting. Because, let's say this is 6 by 6. Okay, so now I've got one, and I can put another one, let's say maybe over here. So maybe this one is 4 by 4. Again, these are going to be a different color. What I really want to be able to see is which are the similar shapes right very quickly. With triangles, this is the one area that if you can't figure it out, I'll allow you to put an equal triangle next to it. Little bit of a cop-out, but if you're struggling, go for it. I'm not going to penalize you for that. So that's the project. It's going to be a full page of graph paper. So if this is your graph paper, where's my tools? Shapes, there they are. So if this is my paper here, your rectangle on the inside should be about like that. Okay, if you have any questions, see me on D2L. Monday I will be on. Other than that, we are good to go. Have fun with it, and also don't forget to check out the readings. There's a lot of them, but cruise through it, and we'll talk about it next week. Thanks so much, guys. Mr. Paul, out.